Welcome to myprojectbazaar.com. Now we will discuss about the product for partial access mode, new method for reducing power consumption of dynamic random access memory. Next we will see the abstract for the product. A dynamic random access memory has served as a main role of storage in computer systems, including high performance systems, personal computer and mobile phones. For more than 30 years, the memory capacity of a DRAM has increased to meet system demands, supported by the development of semiconductor process technology that follows Moore's law, whereby the number of elements on a fixed silicon die doubles every 18 months. In fact, of need from the system side has included not only the memory capacity but also the data transfer speed, operation current reduction, and standby current reduction demand have been placed on the dynamic random access memory do not only have increasing memory capacity and the data transfer speed, but also have a reduced operating and standby currents. When a system uses DRAM, a refresh operation is necessary because of its data retention time restriction. Each bit of DRAM is stored as an amount of electrical charge in a storage capacitor that is discharged by the leakage current. Power consumption for the refresh operation increases in the proportion to the memory capacity. We propose a new method to reduce the refresh power consumption by the effectively extending the memory cell retention time convolution from 1 cell bit to 2 power n cells bit reduce the variation of retention time among the memory cell. Although active power increases the factor of 2 power n, the refresh operation time increases more than 2n, and as a consequence of the fact of the majority decision does better than the averaging the tail distribution of retention time. The conversion can be realized very simply from the structure of DRAM array circuit, and it reduces the frequency of the disturbance of power consumption by 2 orders of magnitude. On the basis of this conversion method, we propose the partial access mode to reduce the power consumption dynamically when the full memory capacity is not required. Next, we will see the flow diagram for the product. First, we will put the input for the input data bit and then go to the PAM circuit implementation, then the PAM entry operation. PAM means partial access mode. The partial access mode entry means the copy the partial access mode memory cells values, the copy flag to be input for the PAM circuit implementation, then the partial access mode access operation, the N1, N2, N3, N4 inputs to be applied to the PAM circuit implementation. The N1, N2, N3 means number of word line selections to be applied for the PAM circuit implementation. The N1 means 2 bits selection for the 1 bit selection for the PAM circuit implementation. N2 means 2 bit PAM circuits word line selection for the PAM circuit implementation operation. Then go to the mismatch between the area auto refresh operation in the normal mode and the preserved bank data in the PASR have been explained. Our proposed PAM eliminates this mismatch. Use all the memory cell efficiency. One characteristics of the PAM that is hold the data using 2 power n cell and bit to the extension time. The PAM entry operation indicates the conversion from the 1 to 2 power n cells bit. This is the simply of copy operation from the memory cell connected with the 1 word line to 2 power n minus 1 memory cells connected with this operation is simply achieved by the DRAM array structure. The operation of the performed by only the delayed WN selection. The PAM entry operation completed through the 8K by 2n copy operation applied to the all memory cells in the 256 MB DRAM. In the PAM access process, 2 power n memory cells compensate for the each other storage charge by selecting the 2 power n word lines at the same time in both normal and self modes. They enable to extend the data retention time, which analyzed by the later section. The PAM. Next, we will see the PAM output. PAM circuit implementation output to be processed by the partial access mode 4-bit decoder section. The decoder architecture to be optimize the PAM operation. The PAM operation to be optimized by the power level and the delay performance for the PAM circuit implementation. Then the PAM circuits to be processed by the PAM circuit implementation for the decoder operation. The decoder operation output to be displayed by the address bit values and the selection of word lines based on the number of PAM access inputs. Then the copy operation for the copy flag mode to be used for the PAM circuit implementation. Then finally PAM exit conditions. The PAM exit condition operation indicates the reconversion from the 2 power n cells bit to 1 cell bit, which is necessary to because the storage charge in the 1 memory cells not enough to read 1 bit. 2 power n times for the recharge in PAM used 2 for 1 bit. The PAM exit operation simply continues the 8k by 2 power n refresh operation to all memory cells in the array circuit. It's very simple manner. This is the flow diagram for the PAM partial access mode operations. And finally we will see the output for the product. First we will go to the implementation of the VHDL coding, then synthesis the final output product. Run the synthesis report, then run the process for the every VHDL coding. They display the error and warning to be displayed by this window, then successfully compiled by this operation. Next we will see the RTL schematic diagram for the product, then run the RTL schematic diagram, then add the blocks for the RTL schematic diagram, then create this schematic diagram. This is the input schematic diagram and this is the output for the schematic diagram. This is the inner part of the schematic operation. The various blocks to be included by the circuit. In our every blocks to be inserted the some set of circuit operations. Then finally we will see the technology, view the technology schematic diagram. Also the same process for the technology schematic diagram. Then go to the output for the simulation output for the VHDL coding. Then simulation process to be applied by this circuit. Then simulate the input operation. Then simulated the number of signal lines. Then go to the final input for the given simulation input. Then simulate the number of inputs for the operation and given to the every input for the simulation output. Then input for the simulation process. Then finally in every input a number of input data and number of the word line selection data to be displayed by the output process. Thus minimize the process for the simulation graph. Then finally output for the 00 for the input and decoding output operation for the first bit 00. Select the first bit and 000. Then next decoder 100 for the output process. Then input to the play the 10, then 10 for the input. So we will select the third bit for the output process. Is the performance for the existing decoder operation, and CP circuit to be copy the flag operation, and the N1, N2, N3, N4 is a number of word line selection bits to be processed by this output process. Then the CP is equal to copy block, then the partial access results to be copied by the next block of the operation to be displayed by this operation. The copy block to be input to the 1, then copy the same operation for the process output. This is the final output for the power reduction DRAM product.